Bismillahirrahmanirrahim. Assalamu alaikum. Our today's topic is about Arrhenius theory of acids and bases. Now let's get started. Arrhenius, a Swedish scientist, put forward a theory about acids and bases in 1887. Acids produces H positive ions when dissolved in water. For example, HCl, H2SO4, H2CO3. HCl is hydrochloric acid, H2SO4 sulfuric acid, H2CO3 carbonic acid. When HCl dissolves in water, a process of dissociation takes place and a molecule of HCl dissociate into H positive and Cl negative ion. Base. Base produces OH negative ions when dissolved in water. For example, NaOH, CaOH twice. NaOH sodium hydroxide, CaOH twice, calcium hydroxide. When NaOH dissolves in water, a process of dissociation takes place and a molecule of NaOH dissociate into Na positive and OH negative ion. According to Arrhenius theory, acid is a substance that gives H positive ion on dissolving in the aqueous solution. It increases the concentration of H positive ions in the solution. The base is a substance that ionizes OH negative ion by dissolving in the aqueous solution. The concentration of OH negative ion is high in the solution. According to Arrhenius theory, acid is a substance that gives H positive ions on dissolving in the aqueous solution. In acids, blue litmus paper turns into red in acidic solution. Arrhenius acid in the aqueous solution increases the concentration of protons or H positive ions. For example, hydrochloric acid in water, HCl undergoes dissociation reaction to produce H positive ion and Cl negative ion. As explained below, the concentration of H positive ions is increased by forming hydronium ion. When HCl dissolves in water, it dissociates into H positive and Cl negative ion. The concentration of H positive ion is increased by forming hydronium ion in aqueous solution. The lone pair of oxygen attacked on H positive and form hydronium ion by the removal of chloride ion from HCl. Other example of Arrhenius acid is nitric acid, that is HNO3. When HNO3 or NHO3, it is nitric acid, when it dissolves in water, hydronium ion is formed H3O positive by the removal of NO3 minus. In this reaction, nitric acid dissolves in aqueous water to give hydrogen and nitrate ions. These are the examples of Arrhenius acids, that is hydrochloric acid HCl, nitric acid HNO3 or NHO3. It is the same acid. Sulfuric acid H2SO4, phosphoric acid H3PO4, carbonic acid H2CO3 and acetic acid CH3COOH. When acetic acid dissolves in water, it, it is dissociate into CH3, COO negative and H positive. Arrhenius base. An Arrhenius base is a substance that increases the concentration of hydroxide ions in the aqueous solution. For example, the example for Arrhenius base is highly soluble sodium hydroxide compound in water, which dissociates to give sodium ion and hydroxide ion. In aqueous solution, NaOH completely dissolves to give hydroxide ion and sodium ion to increase the concentration of hydroxide ions. When NaOH dissolves in water, Na positive and OH negative is formed. It is the aqueous solution of sodium hydroxide. It is completely dissolved to give Na positive, that is sodium ion, and OH negative, that is hydroxide ion. Some other examples of Arrhenius base are first and second group hydroxides like LiOH, lithium hydroxide, and BaOH twice, barium hydroxide. When LiOH, that is lithium hydroxide, dissolve in water, it dissociates into lithium ion and hydroxide ion. Examples of an Arrhenius base are listed below. That is sodium hydroxide, NaOH, potassium hydroxide, KOH, calcium hydroxide, CaOH twice, and magnesium hydroxide, MgOH twice. They all give OH negative ion when they dissolve in water. Now summary. According to Arrhenius theory of acid-base, acids are those which readily dissociate to give the hydrogen ions in aqueous solution. Alkaline species dissolve in aqueous solution to give hydroxide ion. All those bases which dissolve in water, they are called alkali or alkaline species. The bases which readily dissolve in water. The general properties of acid and base. Acids are acidic in nature, bases are basic in nature. The concentration of H positive ion is high. The concentration of OH negative ion is high. Acids are sour in taste, bases are bitter in taste. Acids uh, are red on blue litmus paper, means in acid blue litmus turns into red color. while in bases are blue on red litmus paper. It means in bases or in alkaline solution, red litmus turn into blue color. The pH of acids are smaller than 7, have pH smaller than 7, and in bases pH is larger than 7, have pH larger than 7. Common examples are lemon, oranges, vinegar, urine, sulfuric acid, hydrochloric acid. Common examples of bases are soap, toothpaste, bleach, cleaning agent, lime water, ammonia, wat- ammonia, water, and sodium hydroxide. Now, limitations of Arrhenius theory. The Arrhenius theory is applicable only in aqueous solution. For example, according to the theory, HCl is an acid in the aqueous solution, but not in benzene. Even though it donates H positive ion to the benzene, also under Arrhenius definition, the solution of sodium amide in liquid ammonia is not alkaline, even though amide ion deprotonates the ammonia. Thank you very much. Allah Hafiz.